So let's get started. So first of all, welcome everyone to the session on or the webinar on data analysis in Python. Basically, we'll be concentrating on Numpy in today's session. Right? As you might be knowing, if that I am Manish, and I'll be taking this 2-day session with you guys. If somebody does not know, my name is Manish, and I have around 10 years of total experience. And I have been taking Python and data analysis sessions quite a long time now. And I have been working in Python data analysis, machine learning, deep learning, NLP from some time now. Right. I have been teaching Python and data analysis and machine learning from few years, and I basically like to do that to share my knowledge with other people that I get. Right? Yeah, what are the topics are we covering today? I'll talk about the agenda. Just give me a minute. Let me start sharing my screen and just look into the agenda real quick. Right, so today's agenda would be okay. So I'll be using Jupyter Notebook for my sessions. Okay. So whatever I'll be speaking, I'll be making notes here, and I'll be simultaneously, running some programs, running some lines of code, so that you can get a, that the moment only you get the code run, right? And you get what's the output and what's the expected thing and how does it work and everything like that. So I'll be using the Jupyter Notebook throughout both the sessions. Okay. So the agenda for today basically would be topics on what is Numpy, right? So we'll be looking what is Numpy, and we introduce Numpy, right? Okay, and then we will see what are Numpy arrays, okay. And few of the properties of Numpy array. All right. Then we'll try to we'll create arrays in different ways. We'll see how to create arrays and in different ways, and we'll see how to index and slice, right? Numpy arrays. Okay, so this is the agenda for today. Tomorrow we'll see mostly the functions, array functions, and some of the operations that we can perform on arrays, and a few of the applications like solving equation using Numpy. Right? So this is the plan basically, and today we'll try to cover this. It might go here and there, slightly here and there. Ideally, this is the plan, but we can incorporate other topics today, or it might overflow tomorrow as well. Right? But we'll try to stick to the agenda. So will we get the notebook for 2 days? Yes, you will get the notebook. I'll share with the team and they can share with you. All right. Cool. So again, any other questions before we start? Cool. Yeah. So I was saying, I have an assumption that you guys are familiar with Python and the basic fundamental data types in Python, and you can write basic programs in Python, right? So let's jump to the first thing today, which is what is Numpy, and what we'll introduce Numpy, and we'll see what exactly is Numpy, right? So can anybody tell me, or does anybody have any idea that what Numpy is?
Numpy is the library.
Okay. Numpy is a library.
It is used for the numerical calculations.
It is used for the numerical calculations. Okay. Okay. So yes, Numpy is actually, it is in a short form of numerical Python. Okay. And as the name suggests, it is used to basically mostly used for working with numerical data. Okay. Used for working with numerical data. And yes, correctly said that it is a Python library. Python library. This is which is used for working with mostly with numerical data. And most important thing that one of the most important thing that NumPy provides is it provides a multi-dimensional array. Okay, provides a multi-dimensional array object. That's what it does, and it also provides multiple functions. Yeah. Provides functions that can be used, right, to perform mathematical, or you can say numerical, right, and numerical operations on arrays or matrices, right? So that's what in brief about what NumPy is and what can it do, right? And what does it provide to us, right? So NumPy provides its own data type, right? Which is the NumPy array. And it is as the name suggests, it is an array, and it's quite similar to how a list in Python looks like. All right. And we will see that what are the differences between a list and an NumPy array in a while. But that's how you compare a list with an array. Right? So if you understand, you have an image in mind what list is. It's similar to sorry. Yeah, arrays are similar to a list in Python. Right? So any questions so far? All right. One expectation would be from me that please be interactive so that we can have a fun session. All right. Cool. So what are like, now we have seen what NumPy gives us, right? What NumPy has it provides us. So it's very fundamental and very um, a, a very basic library that Python provides, right? And basically it gives you a multi-dimensional array object, from which we can perform multiple mathematical functionalities like a linear algebra, algebraic uh, uh, solutions we can get from the NumPy directly. No need to solve that, right? It provides functionalities, right, to perform linear algebra, basic linear algebraic operations, sometimes statistical operations as well, generating random samples, dealing with matrices functionalities, right? All those things it provides, right? And to start with, we'll basically start with one of the basic things that I've already spoken about, multi-dimensional array in NumPy. That's basically it's you can say the core thing that NumPy provides, right? And it provides an n-dimensional, multi-dimensional array which contains homogeneous data types, right? And mostly numerical data types, so that as the name suggests, it's we work on the numerical calculations with the array. So it mostly provides numerical data so that we can perform numerical operations on that array. Right. And there's one saying about NumPy is it's quite fast. Right? It provides you fast mathematical calculations, which internally performed by NumPy. And when you compare with lists per se, it basically is faster, evidently faster than lists. Right? We'll see an example where we compare a list, same calculation done using a list and that too when we use a NumPy array, right? Okay, so let's get started with what a NumPy array is, right? Okay. So can you tell me if you are coming from a different language as well, you must be knowing what an array is, or if you're familiar with Python, you must be knowing what a list is, right? So can anybody tell me what an array can be?
Collection of homogeneous elements.
Okay, it's a collection of homogeneous elements.
Array
Your voice is breaking down. Okay, so what are arrays in Python are? We usually, specifically provides a data structure or data type, which is called an ND array. Okay. So what an array is? Yes, array is a collection of homogeneous data types. It's basically kind of a container, right? Which contains a very large uh, data set, but more majorly numeric data set, right? That's what NumPy array is, right? And NumPy arrays basically are fixed size when we create. Okay? And that's the main one of the differences between a NumPy array and a list. When you create a list, right? If you remember with lists, right, we can dynamically change the size of the list, right? We can delete elements from a list. We can add elements from in a list. So lists grow and can shrink dynamically. But on the contrary, NumPy arrays are of fixed size when we create them, right? And when we try to change the NumPy array or an ND array, it basically what it does, it creates a new array. It does not modify the existing array, because if you're changing the size as per the property of a NumPy array, it should not be changed. So when we change it, it basically creates a new array rather than changing the existing array. It creates a new array and the original or the previous array gets deleted. That's how basically a NumPy array behaves. Okay? And generically, the elements inside a NumPy array are supposed to be of homogeneous data type or the same data type, right? And which gives, there are some exceptions to that. Okay, we might see it later, but NumPy arrays should be of all homogeneous data types, right? And this NumPy arrays actually provides you multiple functions that basically gives functionalities of multiple mathematical basic and advanced mathematical operations on numbers, right? Majorly numerical data. And as I said earlier as well, these operations are very efficient when we use NumPy rather than using a list or any other data type. Okay. It's directly available, right? There are multiple functions directly available, and you can directly use these functions to perform an operation rather than writing a few lines of code using list. Right? Even the internal working is pretty faster compared to when you use a list. Right. So let's see how basically we can create an array and see their properties. What are the attributes associated to an array on a very basic level? So for one way of creating a NumPy array is basically very simple way. You might have a list, right? Or let's call it L1, and you have elements such as 1, 2, 3, 4, and 5. Right? This is basically a list. Okay. And before we jump into NumPy, we basically need to import this library, which is the NumPy. because it is not directly available. It's not a built-in library that is available. It's actually need to be, ideally speaking, it has to be installed. All right. It's a third-party library used in Python, but it has to be installed first. Since we are using Jupyter Notebook via Anaconda, we do not need NumPy to be installed because Anaconda provides pre-installed NumPy. But if you need to install NumPy, you're not using Anaconda. You're on a system where NumPy is not pre-installed. You have to install it before importing it. You basically need to use the command called pip install NumPy. So this command will basically install NumPy on your system. So it's recommended to use a virtual environment in your system so that you can segregate your projects. But if not, you don't have a virtual environment, doesn't matter. You can directly install using pip install NumPy. If you don't know what pip is a package manager, you can say, or a tool to basically install and upgrade and manage packages, Python packages, right? So this is a software that enables us to install Python packages, right? So we have to first install NumPy using pip install NumPy. We're not going to do that here because it's already available in the Jupyter Notebook via Anaconda, right? And then we have to basically import this library because these libraries are also treated as modules, and we import modules, right? So how do we import modules? We import any module using import keyword, and we import NumPy, right? And NumPy is generically imported as an alias, right? And how to import any package and provide it an alias?
Import NumPy as NP.
As, right? As is the keyword, and then the alias name. So generically, as I said, it uses NP. This is the convention, not a very convention thing, but it's standard. It has become a standard to use NP for NumPy wherever if you've seen any NumPy code, right? So this is how we import NumPy with an alias, right? So now we have already, if not installed, we install NumPy first, then we import the package using import NumPy as NP. Then we are now can use NumPy and its features, right? And we're going to use NP instead of NumPy because we have provided the alias to that, right? Any questions at this point, anyone? All right. Okay, so just going back to how does a NumPy array look like? So we have created a list here, right? L1 with 1, 2, 3, 4, 5 elements, which are all integers, right? So what we're going to do is we will basically create a NumPy array, okay, using this list. So I create ARR1. This is the variable name I use for creating a NumPy array, equal to np.array. Okay. This is the method basically we use to create an array, and inside this, the argument I'll provide it as the list that I have created in line number 3. Okay. So as soon as I execute this list gets converted into a NumPy array, which we see here. Okay, this is how it gets represented. All right, and how to check the data type of any variable?
Type
Function. So use the type function to check the data type of any variable. We do this, and when we see here, we get numpy.nd array. So as I was talking, multi-dimensional arrays are called nd array, right? That's the data type that is being used for a NumPy array, right? Since it's part of the NumPy library or the module, it is prefixed by NumPy. All right. So this is how we create a create an NumPy array using a list. Right? Now, let's see a few of the attributes associated with NumPy, NumPy array, basically. So what are the attributes which we're going to see is, first thing it would be array1 dot size. Okay. This basically gives the number of elements present in that array, all the elements, individual elements present in the array. So there are 5 elements inside that array, so it gives 5. Right? There is another attribute which is available with NumPy arrays are ndim. Ndim provides you the dimension, the number of dimensions this particular array has. So can anybody tell me, by seeing the array, what dimension this array is?
1 cross 5.
No, what's the dimension?
1D.
1D, right? Because there is no array of arrays inside it, right? So it's a 1D array. Right? So array.ndim will give you 1. So it's a linear, right? It goes like this. So basically there is no array of arrays. So it is a 1D array. Now, there is another attribute called shape with an array. Shape, it basically is used to describe what is the shape. Basically, can you tell me what a shape would look like?
1 comma
Rows
5.
and columns.
1 comma 5.
Yeah, it basically, if in a 2D array, if you visualize, it looks like rows versus columns, right? So as said, that it should be 1 comma 5, but only with a NumPy array, shape would be not 1 comma 5, but 5 comma. It means it's a 1D array with 5 elements. Okay? This is how it is represented for a 1D array. All right. Now, for example, I have L2, which is 4, 5, 6, and L3, which is 7, 8, 9. Right? These are 2 lists that we have. And what I do is I create an array2, arr2, which is numpy np.array. And inside this, I provide like this, L2, comma L3. So if you see here, I'm providing a list of lists, right? So if you print array2, what do you see?
Array of
2-dimensional
array.
array.
2-dimensional array, which also looks like a matrix.
It's matrix, yeah.
It's a 2D matrix. Right? So if you see, you can do the same thing with this array2 of size. So what does size give us? Size gives us the how many individual elements are there in the array, right? So what does size for array2 will give you?
6.
6, because there are 6 elements. So it gives you 6. Size will not give you the length, which basically does not give you how many elements are there in the outer array, right? It gives you all the individual elements present in the ND array, right? Which is 6. Now, ndim is the other attribute which gives you the dimension of the array. So it will give you
2.
2, because it's a 2D array. Right? Now, coming to the shape of it, shape provides, basically, it describes the shape is nothing but how many rows and columns, right? That's what it does. So how many rows are there?
2 rows.
2
2
rows,
rows, 3 columns.
3 columns. So if you visualize this, it looks like the same, right? one row, two row, 1, 2, 3 columns.
Yes, yes. So shape is like 2, 3.
Sorry.
Yeah. No, shape is 2, 2, 3. Is the
Yeah.
rows and
Exactly. So the shape would be nothing but 2, 3. Right? How is it basically visualize this? So we have this 4 and 5 and 6. So 4, 5 and 6, 7, 8 and 9. So it is treated as this matrix which has C1, C2, C3. This is the columns and row 1 and row 2. Right? So 2 rows, 3 columns. So this is how it looks like in a 2D array.
Hi Manish, I have one question.
Yes, please.
So we are using list and we are now converting that into the NP Numpy array.
Yes.
So how does it difference? Because it looks like array. And,
Yeah, it does. Yeah,
it is
we'll
array.
come to that. We'll see the differences between a list and an NumPy array
Okay.
soon. Yeah.
Okay.
So any more questions, anyone?
Can you please explain the part shape for 1D matrix again?
Okay. So yeah, so I'll go there. So I suppose this is how we visualize a shape, right? 2 cross 3, something of that sort. Number of rows multiplied by number of columns, or number of rows and number of columns. Okay? This is how it is visualized in 2D or 3D or 2D plus arrays. Right? But what happens in case of 1D? The representation is not 1 cross or 1 comma 5, right? Okay. For some reason, they represent it like how many elements are there and comma, which means by default it's a 1D array. Okay. They do not write it as 1 comma 5. If you see, it's a 1D array with 5 elements, right? Right. If you see here, it's a 1D array because the dimension is 1 and the size is 5. But instead of writing 1 comma 5, okay, this is not how they write it. In how we get the shape for an ND array. Instead of that, we get right 5, which means there are 5 elements, and by default, the size, if no size is present, nothing is present here, it means it's a 1D array. Okay, that's how it is interpreted.
Okay, got it. Thank you.
Cool, no problem. Okay, any other questions, anyone? Let's go to the topic wherein we see few differences, basic differences between a list and a NumPy array. So again, we'll see a few properties of an NumPy array over there by few examples, right? So as we know, the array is some kind of a data structure that NumPy provides, right? And now ND array is a data structure or a data type which NumPy provides, right? Associated with NumPy. It basically gives you the numerical, mostly it is used for putting the numerical data such as matrices and to perform algebraic expressions, right? Calculations. So it is, so we have seen a 1D and a 2D array, right? And how basically, and that's why it is ND array. So I want to make that point clear. And when you see the data type of any of these, array 1 or array 2, basically says ND array means whatever the dimension, D array. So this array 2 is a 2D array and array 1 is a 1D array, right? So that is what generically speaks told as ND array, and so on and so forth. Okay. So and we have seen some of the attributes, and also we will see there's something called access, right? what is access in terms of arrays? It basically will make sense on a 2D array wherein, right? When a 2D array looks like this, right? So it's a 4, 4, 5, 6, and 7, 8, 9. In this case, we have we have two axes, right? One is having 3 things, and another one is having 2. So rows and columns are nothing but are also said as axes, right? And one way that we saw to create a NumPy array is using a list. We convert a list into a NumPy array. That's only one way of creating it, right? And from there, it comes the question of basically, what's the difference between a NumPy array and a list, isn't it? So we'll see other ways of creating a NumPy array as well. But before that, let's see, how it is different then, right? How NumPy array, why do we use NumPy array instead of a list? Why there is a so much fuss around a NumPy or an ND array? So to start with, theoretically, I would like to say that a NumPy arrays are quite faster compared to lists, right? And they are more memory efficient as well. The way they are stored in memory are basically NumPy arrays are efficiently stored in the memory when compared to lists, right? And the operations, as I spoke about, are on a NumPy array is faster than when you compare the same operation when you do using a list, right? And let's see a few other differences on a NumPy in a NumPy array and a list. So basic differences are, let's say, for example, I'll just take the list one, L1 again, right? And I have array 1, right? So both look similar, and both of them have the same element, right? Now, for example, we have, let's say, something called, or let's do one thing. Okay. When you perform, can you perform a multiplication or a star operation on a list? Can you do that? Can you do this?
Yes.
What do you get as an output?
3, 6, 3, 6, 9, 12, 15.
Are you sure about that?
Yes.
No, 3 times element will repeat it.
3 times these elements, whatever is there in the
Okay.
on L1 will be repeated, right?
Yes.
Star operation does not do multiplication operation. It does repetition operation, isn't it? In a list, it repeats whatever elements are there 3 times, right? It creates a new list, and in that it puts the repeated elements, how many times we have given here, it does that, right? Now, if you perform the same operation on a array, see what happens.
Multiplication.
It actually multiplies each element of this 1D NumPy array with 3, and we get 3, 6, 9, 12, and 15. Right? Getting the difference?
Yes.
All right. Now, for example, I have something called L2, and this L2 has 10 in that. Okay, only one element. So we have L1, 1, 2, 3, 4, 5, and L2 has single element with 10. So can you do L1 plus L2? Can you do this?
I'm not sure. Maybe we should make concatenation.
Yes, you're right. It will concatenate. It's a concatenation operation, right? So 10 will be concatenated, which is the element of L2 will get, concatenated with the elements of L1. So we get 1, 2, 3, 4, 5, and 10, isn't it? Right? So this is not an arithmetic addition, right? It is a concatenation operation in case of lists, right? Now, we do the same thing. For example, we have array 2 and we have np dot array, and in that we write 10, right? So this is the same thing that we have. Array 2 is this, array 1 is basically 1, 2, 3, 4, 5, and I do array 1 plus array 2. See what happens. Okay, so each of the element of array 1 is added by the element that provided as a, which is the 10, with each of the element gets added to that basically, and we get a new array with the added elements. 10 gets added to all the elements 1, 2, 3, 4, 5, and we get a new array. So this is how it behaves differently, right? And this operation, any operation which we perform with two arrays like this is called broadcasting of arrays. Okay, this is called broadcasting of arrays. Any questions at this point? Cool. Now we see another thing. Let's see the same thing with another example. Here we try to add 10 as a 10 was the element of a list L2, right? So you can perform on a concatenation on two lists only, right? Can we do L1 plus 10? Is it possible? Is this possible with lists?
No, these are like two different data types, right?
Two different data types, so lists cannot be added with an integer. So you give a type, you get a type error. Okay? Can only concatenate list, not integer to a list, right? So the previous one worked because both of them were lists. So L1 was also a list, L2 was also a list, right? And here, in case of Numpy arrays, we have defined array 2 as 10 as an element, right, of a 1D array. Now the same thing can be written as this as well. So your array 1 is 1, 2, 3, 4, 5. Array 1 plus 10 basically will do the same thing what array 1 plus another Numpy array with a single element 10 does, right? So this basically will add 10 to each element of your array. Okay. All right. Now, for example, if I want to do this operation, right, I want to add 10 to each element of a list, right? So I have 1, 2, 3, 4, 5. I want to add 10 to each element of a list, and the output I want in a list, right? How should we do that? How do we do that? So we have L1. We need the output to be this, right? Using L1. Using loop. Yes, it is. That's right. We'll use loop, isn't it? So what we'll do is we'll create a loop for I in L1, right? Then we first define a list, and then in that list we keep on adding 10 to each element, and we print the value of out, which is a list, and we get 10, 11, 12, 13, 14, 15. So this operation can directly be performed like this using an array, right?
But using a loop, we take more memory than just to
It
add
does. Exactly. And it is slower as well. Okay. Later on, we'll see an example wherein we'll calculate the time taken by an operation done on a list and the same operation done using NumPy. We'll see the time difference as well. Right? So more memory and time, NumPy arrays are more more memory and time efficient compared to lists. All right. Cool. Okay. So let's see another way. How can we generate, an array? Okay. So there is a function provided with NumPy. As we used array as a function associated with NumPy, there is another function which is called arange. Okay. This particular guy, it works like the range function, the inbuilt range function of Python. It works similar to that. We'll see that in a while. So, but there is a difference in that. So that also we will see. We'll look into it. So let's say array 3 I could try to create, and I give np.arange. Okay, and here we provide let's say 10. Okay, if you see here, it works similar to range as I speak, right? So you have L3, which is equal to range 10, and if you print L3, this basically is a list of 0 to 9, right? So a range works similar to what a range function gives you, right? It's a basic example of that. But what the difference is here, basically, now, can you generate float numbers or floating point numbers using range? Is it possible?
No.
Okay. Is it possible to have a step size of floating point? No, right? You can't have even the step size as floating point, nor even the start and the stop parameters as floating point. So it will always generate an integer value, right? So, but in a range, you can basically generate something like this. Want to start from 10, go till 15, excluding 15, and in a step size of 0.75. Right? You get a 1D array of 1, 2, 3, 4, 5, 6, 7 elements. Okay? Because that's how the ending point we gave it here. Okay? So this cannot be done using range. So this is how a range function also create a NumPy array. It provides you a NumPy array as a output. Right? If you see A3, the type of array 3 gives you an ND array. Okay. All right. Okay, there is one more attribute that I forgot to speak about. In case of this ARR3, right, or any array for that matter, there is an attribute called dtype. You see the dtype attribute, you get the data type of the element that is there in the array. So these are integer data types. So you get int 32 as the data type of this NumPy array. All right. Now, if I assign this to a variable and check the d type of that, for example, here we are generating float values. So if ARR4 of d type would basically give you a float 64. So this int 32 and float 64 are basically not the native or the fundamental data types of Python. These are associated with NumPy only. These are the data types created in the NumPy library, inside the NumPy library. But internally, it uses the fundamental data type, which is integer and float. Okay? It behaves exactly the same as that only. Right? Any questions at this point?
Sir, in 32 means for each element it will take a 32 bits.
Okay. Yeah. So let's see what that is. You can use the help function to check that. Right? So what you can do is, I think int 32 or np dot. No. Try this. So if you see here, it's a class. Okay, that's how int is a class, right? It's a data type associated with NumPy module, and it basically is of range this, right? And it is basically taking 32 bits. Right? There is something called int 64 as well, whose range is greater than int 32, if you see here, and it takes 64 bits. Right? I hope that is clear.
Yes, thank you.
All right. Now we saw, yeah, go ahead.
Is it possible to use help function for float?
Yes, we can. np.float64, that's what I want. It does not have any range, but it is 64-bit precision floating point number. Right? And this is how it is internally classified. 11 bits are used for exponents, 52 bits for mantissa. So it's internally stored in this way. 64 bits are divided like this. Okay. These are similar to the if you're coming from C, you will understand. So it's basically coming from there. It's similar to the C int 34 double and the long and stuff like that. Right? But in fundamental native Python fundamental data types, we do not have any range, right? We directly have an int and we directly have a float. We don't have a double or a short or a long or anything of that sort. But NumPy provides you that this kind of data types basically. All right, so let's move. So we saw two methods, one using numpy np.array to create arrays. We converted a list into an array. We also saw one more function which is called the arange to create a 1D array. Right now we'll see a few other methods, basically how can we create arrays, right? So I think, yeah, does it come here, and then we'll see slicing and indexing. So how can we create arrays in other ways, right? There are other functions that we have in arrays that we, NumPy, that we can create arrays using that. So the first function that we're going to see is basically which is called the zeros function. Okay, this is basically np.zeros. What this function do is basically, this function is, these are special, it creates arrays of special types, basically, some kind of specific types it creates. Okay, so as the name suggests, zeros will create an array with elements, values as
Zero.
zero, right? So let's see an example. So let's say Z1, I create an array and I give np dot zeros, and here I give, let's say 10. So what does it do is basically, and I print Z1, it creates a 1D array with size 10, and all the elements are zeros.
Looks like it's good for matrix operation.
Sorry, I didn't get to that. It's good for?
It's good for operations with matrices, something like this.
Yes, it is. So since it's a 1D array, it looks like this. If you want to create a matrix with all the elements as zeros, you can do that as well, right? So what you can do is Z2 np dot, zeros, and instead of giving the size here, right, you can give the shape as a tuple like this. So you can give 3, 3. It gives you a 3 cross 3 matrix, which is a 2D matrix. You print Z2, you get a 2D matrix of size, of shape 3, 3. You can verify that as well. Shape is 3, 3, which is what we have given it here, right? And the dimension of Z2 is 2. Right? And by default, the data types looks like they are D type is float 64. If you want to have the data type as integer, that also you can have. And just give a comma, provide the parameter name argument as D. I think it's D type, if I'm not wrong. And you can give int 32, and you get an int 32 zeros. These are not now floats. By default, it gives you float, right? Now, there is another function called once. np.once. This is similar to zeros. Instead of zeros, once will give you that particular shape or size array as once, right? So let's say O1 equal to NP dot ones, and in brackets, let's give a 2D array here in this case, and we give 3,4 and print O1. We get all ones, and by default, again, this is floating point. We can change it to integer. That we can do. But we get a 2D array with shape 3,4 with all ones, with these values once here, right? There is another function that is called full. Okay. This method basically is used to create, it's similar to zeros and ones, but in this case, we can specify the element value. In zeros and ones, we do not specify the values. Zeros will give you zeros as elements, and ones will give you one as elements. Okay? In full, we can create a ND array or a 2D array, whatever, like ND array, and we provide the value to it as well. For example, I give f1 equal to numpy np dot full, and here I give, let's say, 4,3, and the value to be, let's say, 5, and I give data type or d type equal to int 32. Try to print f1. I get 4,3 shape 2D matrix or 2D array with all elements value as 5. Right? Any okay, there is a question. O1 give O2. What is the result? I didn't get you. Harish, can you please be elaborative with that question? There's no O2, right? So O1 is just a variable name. So what you're looking for in this question, O1 give O2. What is the result? Can you please elaborate your question, Harish? I didn't get that. Anyway, I will move. All right.
Hello, I have a question. Initially,
Yes.
when we created an array, we were using like square brackets. So when we used it for ones and zero, we are using normal brackets. So will it make a difference?
Okay, so yes, definitely. And there's a reason why initially we used square brackets, because we were trying to convert a list into an array, right? Here,
Okay.
ones is a function, and here it takes an argument like this only. I'll show you why we are using a curly brackets here. I'll show you.
Yes.
Let's do a help on any function. So I'll do a help on this. And if you see here, ones takes the first parameter as the shape. So what does shape takes? Shape takes a value of an integer, which we saw earlier. If you provide an integer, you will get a 1D array, right? We initially provide, it was not ones, but with zeros. We give 10. 10 means it will give you a 1D array with 10 elements. Right? As soon as you give shape as a shape of new array, example 2,3, the shape always has to be given in round brackets, right? So we give the shape here. We do not give the elements here, right? So it is expecting a value to be either in an integer. If you give an integer to this, zeros or ones or full, it basically creates a 1D array. But as soon as you give the shape, and shape has to be given in curly braces, curly brackets, right? So that's how you have to give. Making sense?
Okay, okay, yeah. But I tried the other way, it worked, so I just got confused. Okay.
Okay, so you did this
I did just, yeah.
square bracket.
Uh,
So I think it handles it. This function handles it internally. If you give a square bracket, it's a list. Initially, you give this is a tuple, right? So I think it handles internally the way it is written internally, the ones or the
Oh.
full or the zeros function.
But
It handles both the types.
this is the correct syntax, normal brackets, right?
The other ways around is working as well, but since it's like in the example, it is giving like that, so we follow this.
Okay, okay, sure. Okay, okay.
So there's another question which says that what are the applications of NumPy? So few of the applications are clearly evident, right? So it gives you a 2D array, which basically can be treated as matrices, right? If you want to do any operation with a matrix, which we'll see it tomorrow, that you can directly perform matrix calculations with a function which is provided by NumPy. It gives you the calculation in a single line of code. Okay, any mathematical and simple algebraic equations, not algebraic equations, algebraic problems can be solved using NumPy. Any kind of numerical calculations can be easily done by NumPy. So that's one of the basic, applications. Also, when you move ahead, let's say you are doing machine learning, you have a machine learning algorithms. Few of the major machine learning algorithms like linear regression, right? Then we have clustering, right? Then we have deep learning algorithms. These algorithms has to be, using numerical calculations internally, some kind of algebraic calculations internally. So NumPys are used inside these algorithms, right? So anybody who has created the machine learning algorithms are directly available in some of the other libraries, but internally for creating those algorithms, NumPys are used. Even if you want to create your own algorithm, those algorithms will need to do some algebraic or matrix level calculations. So NumPy can directly be used there. These are also, NumPys are also or can be used in majorly scientific calculations as well, right? NumPy can be used, is actually not can be, is actually used in ISRO, right? I'll give you an example as such, right? I had a learner who was working in ISRO, and they confirmed that they basically use NumPy over there as well, right? So what I mean here is, what my point is, NumPy is having application in scientific and mathematical calculations, right? Majorly, right? So this is a major application. Also, NumPy can be used for image analysis. Now, how it can be used for image analysis is, NumPy, an image is basically is created using pixels, right? Pixels in turn are nothing but numerical data, right? And these numerical data can be easily converted into a NumPy array. And these arrays, using NumPy, we can actually modify and analyze the image using NumPy operations. Okay, so these are the basic applications of NumPy. There are major other applications as well, which we might talk about it maybe when we move forward with the sessions, right? All right. Okay, so let's move. So let's see how we what is indexing, how indexing is worked is basically being worked in NumPy, and how slicing is being worked in NumPy arrays, right? So we can take any array. For example, let's go back to our array 1. So this is our array. This is a 1D array, right? It's a 1D array. How to access, and yeah, we are moving towards that one. So the indexing is quite similar to how we index our list, right? So it is basically similar to that only. And how we index a list, same way we'll index here. So it's pretty simple. Array 1 of 0 will basically give you 1, which is the first element, right? Also, negative indexing works with NumPy arrays, right? So let me write it here. All right. Now let's take in another example. Maybe this is array 2. Maybe there is another is another function. There's a module called random inside NumPy, and there's a function inside random which is rand_n, which generates random valued arrays for us, right? So we have given 5 here, so it generates a 1D array of 5 elements. We can simply do this 3, 4. Sorry. Don't have to provide it in brackets. There's difference between you can directly give 3, 4 like that, not in a tuple. Okay? So it gives you a 2D array with 3, 4 shape with random elements here. Okay. So this is how also you can create a ND array with random values assigned to it. Okay. So now let's do one thing. Let's create again array A1 NumPy array. I create like this. I directly provide the values. So I can provide like this. I create a 2D array, 2, 3, 4, 5, 6, 7, 8, 9. So you see here, I created a 2D array. See, this is the outer array, this is the inner array. So it is a 2D array with 9 elements. Right? So if it was a list, assume that it was a list, right? So how do you fetch 5 using indexing?
One.
Array A1 of
1, 1.
1,
1.
yeah,
So
that also you can do. We'll come to that.
1.
1, 1.
Yeah.
Okay. So how it is interpreted as, so if you see this, if you are familiar with lists, right? So this can be also written as this 1, 2, 3, 4, 5, 6, and 7, 8, 9. So we need to fetch 5. How to fetch 5 is, this is this list. Let's assume that this is a list. So 5 is the element of a list which is present at the first index. So this is 0th index. This is index number 1. This is index number 2. So first we fetch the inner list, which is with index 1, which is this full list. Then this list's first element is 5. So we do of 1. So we get 5. So similarly, you can visualize this as well. There is another way to visualize this is, now we have a 2D array. So it can be treated as a matrix with 1, 2, 3, 4, 5, and 6, 7, 8, and 9. So we remember that these are treated as rows and these are columns. Just C1, R1, and R2, all those things are used for representative purpose. So, but if we, let's remove this. Can we say this is a column number 0, column number 1, column number 2, row number 0, row number 1, row number 2, and you want to fetch 5. You want to fetch 5. So we have to write like this: A1 of row of, and in the second bracket column, row and column. So what is the row number? Row number is 1, column number is 1. Okay. Now let's say we want to fetch 9. What is the row?
2.
2, column is
2.
2. Case of 3,
0.
row is 0, column is 2. Right? You can visualize like this as well. So I think this visualization is better than visualizing it as a list, right? So I think this gives you, if you visualize this as a matrix or a ND array, you can directly get the value of, from the index to get the value. You can simply consider the first one as the row and second one as the column. All right. Okay, there is a question. Is it possible to create an array with random elements by providing range? There is a way. Yes, there is a way. I need to check that, but you can explore that. There is a way you can do it. Possible. Okay. Now there is one more way basically. So let's fetch 6, right? If you want to fetch 6, the row number is 1, the column number is 2. Get 6. Now there is another way of doing it. 1, 2. So another way of doing it is like this. So A1 of row and A1 of column. You can also write it as A1 of row, column. These both are same output. Clear? All right. Any questions on indexing? All right. No question on indexing. Let's see slicing. Okay. Now let's take the A1, which we have. We have A1 as this 2D array. Let's take array 1, which is the 1D array. 1, 2, 3, 4, 5. So it works the same way how slicing works with lists. It's exactly the same way. So you do array 1 of 2, 4. What do you mean by 2, 4? So let's take this as this is a 1D array with So we have 1, 2, 3, 4, 5. The indexes are 0, 1, 2, 3, and 4. You are telling 2 to 4 means you start with 2, go till 4, fourth, sorry, my bad. Index 2, right? So start with 2 and go till 4, but excluding 4, right? So it will stop here. So you get second and third index, and the value will be 3 and 4. Right? This is how slicing works. You get 3, 4 as an array. So when you do a slicing on a tuple, you get a tuple and an output. You get you do a slicing on a list, you get a list as an output. You do a slice on a string, you get a substring, right? Basically a string as an output. So you do a slicing on a NumPy array, you get a NumPy array as an output. Right? Now, very interestingly, we will see something. So, okay, before we do this, let's go back to indexing to do something. So, for example, array 1. So, array 1 of 0 equal to -10. Can we do this?
No.
Okay, let's take we have a list. Let's say we have a list. So we have a list L1 with 3 elements, 1, 2, 3. Can we do L1 of 0 equal to -10? Is it possible or not?
Yes, it's possible.
It's possible. So
Yes.
it's not. It's possible.
Mutable.
Similarly, can we do this?
Arrays are mutable.
No.
Immutable. So we cannot do it.
I mean, sorry, arrays are mutable. Yes. Sorry.
Then obviously we can do this. It's like same thing.
So we can do that. Right? I said initially you cannot change the size. You change the size, it creates a new object, right? New NumPy array. But you can change the values, right? Size is not getting changed. Size is the same, right? So this works. You can reassign any element. So these are mutable, right? So now there is an interesting thing here as well. So for example, so if you want to do slice 1, 2, 3, which elements do you get? So this is 0, this is 1, this is 2, this is 3, this is 4. So you get 2 and 3, right? So you get 2 and 3. I'm trying to do this. Is it possible?
No, this is not possible.
It's not possible. So -10, 2, 3, 4, and 5. So I'll write indexes 0, 1, 2, 3, 4. And what I'm doing here is I'm saying slice from 1 to 3, basically 3 excluding. So we get this. And this range, whatever the subslice I get, I am trying to assign 100. Right? This is what I'm trying to do. Let's execute and see what error we get. So we're expecting an error here, right? Do we get an error? No. So what it does is basically it does the slice. It was like this. Sorry, it was not like this. It was like this, and 0, 1, 2, 3, and 4. And we did 2, 2, oh sorry, 1, 2, 3. this is the slice. And what if we assign a single value to it, whatever the slice it has, what it does, it does not print that, it actually assigns that value to both the values, whatever the slice we get. Okay. So it assigns that value to both the, replaces these two with that value, new value. This is what happens. You can see here, that is what is happening. Making sense?
Yes.
All right. Now, array 1 of 2 to 4. Okay. And I do here 20, 50. So when I do 2 to 4, what do we get?
102.
So we get 100 and, no, sorry, 104. Right? These two we get, 104 we get. So we are telling, initially we told one value to be assigned. When we do a slice, 2, 4, we get the value at index number 2 and the value at index number 3. Index number 2 value is 100. Index number 3 value is 4. And we are telling, assign them to two values, which is 20 and 50. So basically it will reassign. So it actually works. 20 goes to index number 2, 50 goes to index number 3. Making sense?
Yes.
Yes.
Now, how many values do we get with this slice? 2, 4?
2.
2. On the right hand side, how many values we are trying to assign?
2.
No, here.
3.
3. Will this work?
Might be error.
There are two possibilities. 20 and 50 will go and 30 will be discarded. Or it will be an error because it will be a mismatch. Right? So if you see here is could not broadcast input array from shape 3 to 2. Right? So it is, if the values are mismatching, if you're trying to change the value and the number of the slice which gets created is having n number of values in the slice, you have to give either one value which will be overwritten at all the places, or exactly n number of values on the right hand side, so that those values go at each place. Making sense? Did this make sense? All
Yes.
right. Cool. Now, another thing we have here, let's take array 1. What's the value as of now? So array 1 is this 10, 100, 20, 50, and 5. So what we do is we create a slice of it, array 1 of 2, 4. And let's say new array I create. So when I do this, so 2 and 3, basically 20 and 50 goes to new array.
Yes.
Right? So when we do this, this happens. Now, for example, now this is a sliced array which we have, okay, with 20 and 20 and 50. Now I change the 0th element to something else, say minus 20. Right? So my new array basically got changed. Right? Definitely yes. But if you see here is what happened in array 1 also, this got changed. Yes.
Yes.
So the elements of array 1 was minus 10, 100, 20, 50, and 5. This was array 1. when we created a new array with using the slice, so slice will be giving us 20 and 50, right? So when we create a slice, this will not create a new object. What happens is it creates a new variable, and this variable actually points to this. It creates a kind of a virtual view, okay, and not a new object, and it will having the same memory location, and new array will be pointing to that memory location, and it will not create a new object. Why? How we are sure about it? Because we had this and we changed this 20 to minus 20. So if we are changing this 20 to minus 20, it is changing the new array. Also, it's changing the array 1 because it's at the same memory location. Making sense?
Yes.
All right. So let's move to having index to see the slicing of 2D array. We have already seen the indexing with 2D arrays. Right? So let's see slicing of 2D arrays. Right. So let's have this guy A1. Right. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. This is what we have. So let's visualize it like this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So this is how we visualize. And okay, before this, let me do one thing. Let me create a A2. Okay. Some random elements I'm creating. I'll create a 4 cross 3 or 4 comma 3. Okay. So this is the array that we have. Now what I do is A2 of before this, sorry. So we have array 1, right? So if I do array 1, 2 colon, and I don't give the stop parameter, what will happen?
It will go to up to the end.
Till the end, including the end, right? So it starts from 0, 1, 2. It starts from minus 20 and goes till the end, including the last, right? So we get minus 20, minus 20, 50, and 5. Right? So let's go back to A2. Yeah. So here what happens is, let's do slicing. So A2 of, if I do 1 colon, for example. So let's visualize this again. So let me annotate. So 4, 6, 1, minus 1, 0, 8, 8, 5, 2, 7, 5. Right? And the rows are 0, 1, 2, 3, 4 rows, 0, 1, 2, 3 columns, right? So now if I try to do this, so what I'm trying to do is, this is representing the rows. Okay.
Yes.
So what I'm saying it as, give me 1 colon means, okay, how do I represent this? Okay, this is, I think like this, it won't be making sense. Let me run this first. So what I'm getting is, I'm getting from 1, go till the end. Right? If I say like this, it basically will, let me use the pen again here itself. So this is 0, this is 1, this is 2, I write it here 0, 1, 2, 3. So on the row place, I'm writing 1 means starting from 1. So like this. Okay. And go till the end. So basically it will take the entire all the columns. Right? Let's take another example. So let's do like this. A2 of 1 colon, comma 2 colon. So what I'm saying here is, sorry, let's take this. It will make more sense. Yeah. So again, this is 0, this is 1, this is 2 columns, 0, 1, 2, 3. So what I'm saying is for rows, go from 1 to end. So 1, 2, 3, all rows will be taken care. So what I do, so this I take, right? So 1, 2, 3, because I'm telling from row 1 to 3 you take full, and in the column section I'm telling from 0 to 2. So it starts from 0 and goes till 2, excluding 2. So basically, this is the thing. 0 and 1 it will take. Yes or no?
Yes.
So what is the common elements? These are the common elements. So we get that as an output. Making sense?
Yes.
All right. Here also, you can create a view, right? We spoke about creating a view. So let's say I create V2, which is using slicing. So what do I do is I do A2 of 1 colon, the previous one only I'll use, and colon 2. So V2 I'll get this, right? So V2 of, if I do V2 of 0 of 1, what am I fetching? What will be the output?
0.
0, right? So this element, and if I do this as 1000, V2 gets changed.
Yeah.
Now you created this V2 using the slicing of A2. Do you think this 0 also will get changed?
Yes.
Yes.
Similar to what we saw in the 1D array?
Yeah.
Because it's creating the view, it is not creating a separate object. Now, let's take A2 again. All right. Take this A2, and what do we do is in A2, how many rows are there and how many columns are there?
4 rows and 3 columns.
4 cross 3.
4 plus 3. Right. Now, A2 of, okay, so what do we do is A2 of This actually is called Boolean indexing. Okay. Boolean indexing. What have we done here is we had this array with, so basically let me clear this off so that I can get more space. So I get 4, 6, 1, minus 1, 1000, 8, 8, 5, 2, 7, 5, 2, and let me write like this. Here. Zero row, first row, second row, third row, 0 row, 1 row. Sorry, 0 column, 1 column, 2 column. So what have we done here is we are saying we have passed a list. Is a list of booleans. So the list element is true, false, true, false. So what this corresponds to is actually it is corresponding to the row of the array. So this is true, this is false, this is true, and this is false. So wherever it is true, it will take that row and put it in the output. So hence we get 461,852. So any ND array, in this case, let's say specifically talk about 2D array. In this case, in this 2D array, what we have done is we have not used indexing as the index 0, 1, 2, 3 like that. We have used another data structure. It can be a Numpy array as well. In this case, we are using a list. This list is having elements, which is Boolean. Okay. So the number of elements of this list should be the actually number. It should be equal to the number of rows in that array, on which we have to apply a Boolean index. So there are 4 number of rows. So we have we have a list of length 4, right? It's a list of length 4. And according to the value of this elements of this list, we basically get that row. What is the what are the indexes of this list, which is basically having true index number 0,
0 and 2.
and 2. Corresponding row numbers of this array will be printed. 0th row and row number 2. Hence the output. Clear?
A question. Is Boolean
Yes.
indexing working with only with rows?
Yes.
Thank you.
Sir, what will happen if we pass true, false to only 3 Boolean?
Okay. Only 3 booleans. In that case, the number of rows is not equal to the number of elements in the Boolean list. So it is an error. Does not match. Boolean index. There are 3 indexes in the Boolean object. Does not match the number of rows, which is 4. Right?
Okay.
If it
Got it.
mismatches, it will not work.
Got it.
Cool. Okay. Let's try to create a list. Let's say my list equal to. Let's try to create something like of this format only and see if it works with columns as well. Right? So we have how many? 3. Each having 3. Right? Or we create a A3 NumPy array only we create. We have 4 rows, right? 1, 2, 3, and 4. And here we have 3 elements. So we have, let's say, true, false, 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 true, false. Will not work, but yeah, just for, let's see what happens. So you have A1, sorry, A2, give A2 of A3, right? Actually, it works. What happens here is, that's what I was suspecting. You have 4, 6, and 1, minus 1, 1000, 8, 852, 852, sorry, 752. Wherever you have false, wherever you have true, that has been taken. So wherever you have true, this is true. This is true. This is true. And this is true. It creates a 1D array. Clear? So if you use a 1D array as a Boolean index of a 2D array in this case, you get the rows that is corresponding to the rows. Now you can also use a 2D array as a Boolean index, right? In that case, whatever the true values are there, that index value will create a 1D array out of it. Making sense?
Looks like it's Boolean slicing.
Yep. Exactly like that, right? So whatever elements you want, create the exact same shape array, and what values, what index values you want, you just make it as true, others make it as false. Those values you will get as a 1D array as an output. Clear?
Hi Manish, I have a question.
Yes, Sandeep.
I understand the bullying, the structure and everything, how it works. But what's the practical use of it in the day-to-day life? Like we can't write this true false many times, you know.
We can't. Okay. So what we can do, I'll give you an example. Let's say there is some data. Let's create data equal to np dot random dot rand n. Okay. And here we give, let's say 4,3. Okay. So data is this array. This is a 4,3 data. So we just visualize this as a row and column. So 0, 1, 2, 0, 1, 2, 3. And let's assume that there is another column. Let's say company. Okay. But it's not part of this 2D array. Okay. It can be a 1D array. We'll see that. Company A, company B, company C, company D. Let's assume that. If you only want the value, the data for company B and company D, you can make this as true and true, this as false and false, as a 1D array. So false, true, false, true, as a 1D array or a list, and pass it to the to the index of data don't you get the data for company B and company D?
Yeah, we will.
So you're getting an example, sorry, an use case for this. If you have some data in a different NumPy array, and you have a 1D array with the elements such as a company or a country corresponding to that data, right? Having the same number of companies as the same number of rows that you have.
Mhm.
Particularly that company data that you need, you can just make that index as true
Yeah, I
and
understand that
get
one.
the value.
But
But
say
manually, yeah, I get your point. Okay, go ahead. Sorry.
so for example, there are like tons of company, like 100 or thousands.
Hmm.
So we won't be able to write true, false, true, false,
Exactly.
true, false.
Exactly. So in that case, I hope this is clear.
Yeah, that is clear. I understand
Cool.
that one, that case.
Cool. Let's say I have companies as, let's say the first data is for company A. All right. The second data is for company B. Third data is for company C. Again, the fourth data is for company A. And this is happening. You have 100 rows and you have random, data for each company, A, B, C, D, or whatever, n number of companies. All right.
Okay.
Now, in this case, we don't have to write. Now, what you can do is simply, okay, let's take this not as a list, sorry, as an array. Okay. Now, you simply do one thing. Companies equal to. Let's say you want the data only for A, right? You do companies equal to A. You get an array with true, false value. Let's say you want data for company A, sorry, B and C.
So can you explain that line number one?
I'll do that. Sorry. Doesn't work like that. Okay, let me come here and then. So what happened here is, we remember with a NumPy array, when you do an operation, that operation happens with each element.
Yeah.
So if let's say there is a array 1, 2, 3, 4, and I do +2, right? This is an array, and I do +2 means it will add 2 to each element.
Yeah.
3, 4, 5, 6.
6.
Similarly, this is an arithmetic operation. Right? Similarly, I can do a comparison operation. Okay. So if I do a comparison operation, if I say this array equal to 2, means it will do this comparison for each of them.
Okay, got it. So
it is doing
index,
1 equal to true. Yeah, it is false. Then it is doing 2 equal to 2.
Yeah.
True.
Got it.
For others, it is giving false and false. So you are getting an NumPy array as an output, which is a Boolean array.
And
So
easily
here,
we can filter out on based
exactly.
Got it.
So when you do companies equal to A, wherever the companies A is there, it basically gives true to that, right? And now you can pass this array to this data, assuming that these companies are exactly corresponding to A, B, C, and then A, and so on and so forth, right? So you wherever A is there, that data you get.
Okay, got it. Okay.
Yep. No problem. Let me try that. Why it was not working for 2 of them? So, how you do is you write data and you write this operation directly here. You don't need to separately create it, right? See, so assuming that, so A is at the which position? 0th position and last position. So you get the 0th row and the last row as output, right?
Yeah, pretty cool.
Right. So let's say you want something like this. I hope it works. Data for company B and data for companies. Let's see. No, it does not. Basically, it does that. Okay. This basically works with pandas, right? But there is a way. Let me check that out. Okay. If you want to, provide a Boolean, want to create a Boolean array for multiple conditions, you can do that. Okay.
Yeah.
So any questions, anyone? So I'm done with today's session. Basically, this is what I wanted to cover. So any questions for today? All right, no questions. Well and good. See you guys tomorrow. Tomorrow, basically the agenda would be we see some of the functions that Numpy provides specifically to arrays. Array functions that we see, right? And some operations and manipulations with arrays we'll see. Okay. All right. And then we will see how some examples such as how to solve a linear equation, and if time permits, we'll see a few more examples in that. All right. Cool. All right. What is it? Then could be very good to see tomorrow example with picture, how to move picture in arrays. Then work with them. All right. I'll try to fit in that example as well at the end of the session tomorrow. I'll try to do that. Cool. Okay. Thank you, everyone, and see you everyone tomorrow, same time.